this lesson we're looking at simplifying trigonometric expressions. So we'll start off by recalling what we should already know. Start off with a unit circle. So we've looked at the unit circle a number of times now, and we've pulled out a bunch of important pieces of information from this unit circle. Obviously, it's important that the radius is 1. We're always looking at the angle to the nearest x-axis. So there's 4 triangles that we focus on, and that cos of the angle will refer to the x, sine of the angle will refer to the y, tan of the angle will refer to y on x or sine on cos. Now, we also understand cast, that in quadrant 1, all of these ratios are positive. In quadrant 2, only sine is positive. In quadrant 3, only tan is positive. And in quadrant 4, only cos is positive. Now, our goal is today to be able to simplify trig expressions. So we'll need this unit circle, and we'll need these understandings. We'll also need the standard triangles or the table that's derived from those standard triangles. So the 2 standard triangles we have talked about is 1, 2, square root of 3, and we're looking at 30 degrees and 60 degrees, and in radians that would be pi on 6 and pi on 3. And the second standard triangle we looked at was 1, 1 square root of 2, and the angles were 45 degrees, and these 45 degrees are the same as pi on 4. Now, these are pretty easy to use. We can find our ratios for the angles 30, 45, and 60 for sine, cos, and tan. The other way we can remember it is a table. So if you can recall, we look at sine, cos, and tan versus the angles 0, 30, 45, 60, and 90. Now the pattern for sine is pretty straightforward. We start at 0, 1/2, root 2 on 2, root 3 on 2, and then 1. Now recall that root 2 on 2 can also be written as 1 on root 2, and that's fine either way. Cos is a reverse of this pattern, so it starts at 1, and we work backwards, root 3 on 2, root 2 on 2, 1 on 2, and 0. And then finally tan is sine on cos, so 0 on 1 is 0, 1/2 on root 3 on 2 is 1 on root 3, root 2 on 2 on root 2 on 2 is 1, root 3 on 2 on 1 on 2 is root 3, and 1 on 0 is not possible. Okay, so basically that's all we're going to use today. These understandings: cast, cos is x, sine is y, tan is y on x, these standard triangles, or the table that we can derive from these standard triangles. Okay, so we'll move down and we'll jump straight into a couple of examples. So example 1 is looking to use the unit circle to find the value of sine negative pi, sine negative 90, and tan 5 pi. Now, seeing this makes me realize that we forgot to review one really important thing, and that's how radians to degrees and degrees to radians conversions. So basically today we're going to be working with standard ones, so we don't have to stress too much, but when we're looking at converting between degrees and radians, it's all about the fact that the radians can be measured by calculating the circumference of the unit circle. 360 degrees is equivalent to 2 pi radians, which means 180 degrees is equivalent to pi radians. We don't have to draw the little c if we're using pi. 90 is pi on 2, 60 is pi on 3, 30 is pi on 6, and then finally 45 is pi on 4. Okay, so now that should be everything that we need. So if we jump back to example 1, it's asking us to use a unit circle to find the value of, and the reason it's saying use a unit circle is because each of these things are on an axis. It just comes down to understanding whether it's x or y on x for each of these. So if we look at the first one, we look at A. Negative pi means we're going backwards 180 degrees. And we end up at this point here. Now if we're talking about the unit circle, we know that in the x here it's -1, and in the y it's 0. And as we're looking for sine of negative pi, we can say straight away that sine of negative pi is going to be the y value, which means that it will be 0. With each of these other examples, with each of these other questions, the approach is the same. So when we look at sine -90, that's a rotation of -90 degrees, and we end up at this point here, where x is 0 and y is -1. So if we're looking at sine of -90 degrees, then we're looking at the y value, which is -1. And when we look at tan 5 pi as our final one, that means we're looking at 5 lots of 180. So starting here, we've got 1, 2, 3, 4, and 5. So we end up at this point, which is x is -1 and y is 0. Now because we're looking at tan, so tan 5 pi, we're looking at y on x. So in this case, we're looking at 0 on -1, and therefore our answer, tan 5 pi, will be 0. So anything that's on an axis, it's just a matter of identifying where it sits, which axis it sits on, what's the x and y values, and what will it be. So if it's sine, it's y, if it's cos, it's x, and if it's tan, it's y on x. Okay, so we'll move on to example 2. Now we're looking at finding exact values, and we got points that aren't on axes. So with each of these, there's a couple of steps. The first one is we sketch it out, and we work out what the acute angle is. So sine 225, that's 180 plus an extra 45. So what we want to be able to say here is that, okay, the acute angle is 45 degrees. Now, once we know that acute angle, because what we look at is these triangles back to the x-axis, we can say that sine 225 will be the same as sine 45, and all we need to do is work out whether it's positive or negative in this quadrant. So if we add on our cast, we know that the only thing that's positive in this quadrant, quadrant 3, will be tan. So sine must be negative. Now the last thing is that we can use our standard triangle, or we can use our table. I'll use a standard triangle in this case. So we've got our 1 square root of 2, 45, 45. And all we're doing is we're going, well, we're looking at sine 45, so let's choose an angle of 45. Sine is opposite over hypotenuse, so therefore it will be -1 on square root of 2. There it is. Sine 225 is -1 on square root of 2. There's our exact value answer. When we look at B, it's a little bit trickier because we're looking at radians, but the premise is the same. Now, in this case, because it's on 6, pi is usually the same as 180 degrees. So if this is pi, which is the same as 6 pi on 6, so if we put all over 6, and over here, this will be 2 pi, and that will be the same as 12 pi on 6. So that means 11 pi on 6 will be pi on 6 less than this 12 pi on 6. So if we go the whole way around, we're 1 less here, and this will be pi on 6. So we're taking the same approach. We've worked out our acute angle is pi on 6. And we can now write that as cos 11 pi on 6 is the same as cos pi on 6. And if we throw in cast, so C-A-S-T, in this quadrant we know that cos is the only thing that's positive. So that means we actually are looking at positive cos pi on 6. Now, the last thing we need to do is work out what's the value of cos pi on 6. So the standard triangle we'll use this time is 1, 2, square root of 3, and 30 and 60. Remembering that 30 is pi on 6. So we're looking at cos. This is our angle adjacent over hypotenuse. So it's root 3 on 2. Means our answer here is square root of 3 on 2. Now we'll look at the third one, and here we're looking at tan 2 pi on 3. So here, because we're looking at pi on 3, this pi is the same as 3 pi on 3. So it means we're going 2 out of 3, and we have 1 left over, which means our acute angle is pi on 3. If we throw cast in here early, we know already that sine's the only one that's positive in this quadrant, so tan will be negative. Okay, so tan 2 pi on 3 is the same as negative tan pi on 3. That's our acute angle. And now we're looking at, let's use green this time, at calculating what tan pi on 3 is. So if we go back over here, pi on 3 is the same as 60, so there's our angle. And tan is opposite over adjacent, so we're looking at opposite of root 3 and adjacent of 1. So that means we end up with negative root 3 on 1, or just negative square root of 3. And that is it. So there's 3 examples where we're looking at calculating the exact value. If we go a little bit further, so now we're looking to find the values without using a calculator. Same idea, but these values are bigger than 360 or 2 pi. So the best way to deal with these initially is realize that there's coterminal angles, and that means there's angles where they finish at the same spot. So when we look at 570, we can realize that that's a full circle, that's 360, plus an extra 180. That extra 180, it finishes at this point, negative 1, 0. And therefore, cos 570 will be equal to negative 1, because that is the x value. When we look at sine 24 pi on 6, and it's negative, so we start here, this will be 6 pi on 6, and then 12 pi on 6, and then 18 pi on 6, and then finally 24 pi on 6. So that means we've gone one full circle, a second full circle, And to get 25, it's 1 more. So we've got an acute angle of pi on 6. And we're in CAST. We're in the C quadrant. So that means that sine will be negative there. So we can say sine negative 25 pi on 6 is the same as negative sine pi on 6. If I just go back up to my table, I know that sine pi on 6 or sine 30 is 1/2. Alright, so when we look at the third one, this is A, this is B, and this is C, and we're looking at tan 11 pi on 2, then we're looking at a scenario here where we've got 11 halves, or 11 90 degrees. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We end up at this point here. Now, as it's on an axis, we know that this point here is 0, negative 1. And so therefore tan 11 pi on 2 will be y on x, which will be negative 1 over 0, which makes this one not possible. Okay, so these ones are a bit harder. It will take a little bit of practice to get used to these coterminal situations. You can do things like, well, cos 570 will be equal to cos 570 take 360, and so on, which sadly makes me realize that this one here is actually incorrect because it doesn't finish on the axis, it finishes, so cos 570 is the same as cos 210, which is the same as negative cos 30. It ends up 30 degrees into this one. So it means that that will end up being negative root 3 on 2. Silly. Okay, we'll look at one last little example. This is a little bit of a step further, but it's actually less working. So here in these ones, this x represents an acute angle. See here it says 0 is less than x is less than pi on 2. So if we can simplify each of these, then we can quite easily come up for an answer to this. We don't have to do anything with 2 sine x. It's already simplified as much as it can. This one here, sine 2 pi take away x, is the one we have to simplify. So if we look at the angle being 2 pi take away x, we end up with an acute angle of x. And if we apply our cast, we know in this section sine will be positive. So really what we're saying is that sine 2 pi take away x is the same as sine x and positive sine x, which means that when we go to simplify this whole thing, this 2 sine x plus sine 2 pi take x will be equal to 2 sine x plus sine x, and therefore 3 sine x. We've got a sine x plus, or 2 sine x's plus an extra sine x, which gives us 3 sine x. Okay, so these ones are the upper level. It's a little bit harder when we're talking about coterminal angles. We've got to be a little bit careful there. And this is our bread and butter. If we can do this stuff, then we're in a good place. Okay, so make sure we practice this now. I'll set some questions that allow you to practice each of these skills. Thank you.